Before we are fully done with the quotient rule, it is important to have a look at a very specific case. This is in your lecture notes as the reciprocal rule. Essentially, when f of x is 1. The reciprocal rule can just be obtained from the quotient rule, so I'll not show you the demonstration, because it is just a specific case of the quotient rule when f of x equals 1. When f of x equals 1, obviously the derivative of f of x equals 0. Because the derivative of f of x is 0, this term disappears, and therefore we can write that the derivative of 1 over g of x is simply given by minus the derivative of g of x over g of x squared. That is because f of x is 1, this term disappears, we still get the minus, and to the power of 2. It is important, of course, to realize that this is a specific case of the quotient rule, even though in your lecture notes and in many maths books it may be referred as a specific rule. As long as you know the quotient rule, you can always get it, so there's no point in actually memorizing it. It can be very useful to get even quicker derivatives. Let's say that you want to calculate the derivative of 1 over x to the power of 3. There's many ways that you could calculate a derivative like this. One way is to use the reciprocal rule. In this case, you want to calculate the derivative of this, as we'll call it g of x. And the derivative in this case is simply 3x to the power of 2. This means that we can use the reciprocal rule to differentiate 1 over x to the power of 3. If we do that, we find the derivative of 1 over x to the power of 3 is minus 3x to the power of 2 divided by x to the power of 3 to the power of 2. X to the power of 3 to the power of 2 is the same as writing x to the power of 3 times 2, which is x to the power of 6. We can then cancel out 2, and we end up with the final answer, which is minus 3 over x to the power of 4. And it means we've shown how to use the reciprocal rule.